Okay, guys, today I'm going to lead the discussion since Ben has an exam that extends through the morning lab. All right, so let's go ahead and look at the first question. So we just want to use the Venn diagrams to check whether or not the following property are true. I would just give you guys about 3 minutes to work on this one. So you wanted to write this, you want to draw the Venn diagrams step by step, which you have your first left-hand side and your right-hand side. And you want to have 3 steps, where the first one's going to be B union C, and the second one is A. And the third one would be B union C minus A. And the one for the right-hand side would be B minus A, and then C minus A, and then the union of these two. All right, just draw the Venn diagrams for these boxes and to see if the property is true or not. If it's not true, just give a counterexample. So anybody wants to share how to do for the first box? How would you draw the first box?
You would fill C. Oh, you're talking about the right-hand side?
The left-hand side.
Left-hand side. For B union C, you would just fill in all of C and all of B.
Mm-hmm.
And then
All right, and what about the second one?
for the second one, you would fill in all of A.
And the last one, if you just do the first one minus the second one.
Yeah, for the last one, you just do B and you do all of B and C except like the intersections with A.
Exactly. Basically, we're just gonna discard like this part. So what we left with are just this. Okay, so did everybody get the same?
Yeah.
All right, so what about the right-hand side, where we have B minus A?
Fill in B without the intersection of like A.
Yep. And it should be this part. And what about the second one?
Fill in C without the intersection of A.
And then you just take the union of this two, which should give you this. And now you can clearly see that your left-hand side is equal to the right-hand side. So no need to provide a counterexample. You could just conclude that they're equal. All right, any question about this one? Cool. All right, so the next problem is to prove this. So you want to show that the left-hand side is a subset of the right-hand side. It's a set problem. I will give you guys about 3 minutes to work on this one. So just remember how you want to prove something is a subset of another thing. All right, anyone who wants to start the proof?
I can do it.
Okay, go ahead.
Let me
get my annotating working. Oh well, I can't annotate, so I'll just explain it.
Yeah.
So basically what I did is I said, let there be an element X such that X is an element of A.
Mm-hmm.
Okay, and then let Y be an element such that Y is an element of B and C. Exactly. And so by the definition of set union, that's the entire left-hand side. And so we just have to prove that that's in the right-hand side. And so X is, and to prove that, by definition of intersection, we have to prove that X and Y are both in the left part of the intersection and the right part of the intersection on the right-hand side. And so we say that X is a member of A union B by definition of set union, and X is a member of A union C by same deal. And so therefore by definition of intersection is a member of the right-hand side, and so it is contained. And then Y, well, since Y is an element of B and an element of C, by definition intersection, Y is a member of the left one because of the B there, that's the definition of union, and it's a member of the right one because of the C there, by definition of union also. And therefore Y is contained in both part of that, so it's contained in the right-hand side of the statement. And because X and Y are contained, then the entire statement that is contained. Does that work? Does that make sense?
Yeah. Yeah, I think your what you said just is correct. But if I would do it, I'll just so first let's just look at the left-hand side. We have the A union B and C. Where you want to actually do is that instead of starting with letting X belongs to A and letting Y belongs to B and C, you probably want to first let let's see where we have let X belongs to the union of these two. And then you can use that as separate cases, where the first case is when X belongs to A, and the second case would be X belongs to B and C. And then for each case would just be the logic you said. Where you just want to use the definition by union or the definition by intersection. So let me just write this in a formal proof, and that would be, so the first we want to let the X belongs to the union of A and B intersects C, where the first case we have X belongs to A. And the second case is X belongs to B intersects C. All right, and we know that since X belongs to A, and by the definition of union, X also belongs to A intersects, A union any other sets, which in this case, X belongs to A union B and X also belongs to A union C. And then also by the definition of intersection, we know that X belongs to A union B and also X belongs to A union C. Thus, X must belong to the intersection of these two sets. Okay, and now then you can conclude that your left-hand side is a subset of your right-hand side.
I have a question.
Uh-huh.
Are we allowed to say something along the lines of A union B intersection C is actually equal to A union B intersection A union C using the distributive property, and being like, because they are equal, by the definition of equal, they have to be subsets of each other?
Yeah, I think you can use that way. It's just like in this problem, we just want to use like the proof by cases.
Got it. But like, would that lose me points, or how would that work?
I think usually, like on the quiz, you would just specify like what kind of proof techniques she's asking you for. So.
Yep, I was just curious. Thank you.
Mm-hmm. Yeah, that's yeah, I think that's kind of right, like in the chat where the proof is actually wants you to prove the distributive property, where it's just one side of the distributive property. Yeah, so in this case, technically I don't think you can use that, but for other proofs that doesn't specify like any techniques she's asking you, so just choose whatever you want to.
So how about case 2?
Sorry, do you want to say that again?
Yeah, I just want to know how to try to prove the case 2.
Yeah.
It's a little bit confused.
Yeah.
I just think I don't know how to use the way like we use in the case 1 to prove case 2. It's a little bit different.
Okay, let's just start on case 2. So the case 2, we assume that X belongs to the intersection of B and C. So we know that by the definition of intersection, X must belongs to B and X belongs to C as well. And that's by the definition of intersection. So then we can see that X must belongs to let me just write this way. X must belongs to any subset, any set that union with B or a union with C. In this case, X belongs to A union B, and X also belongs to A union C. And that's by the definition of union. All right, and the same logic as for case 1, you can say that then by the definition of intersection, X belongs to the intersection of these two sets. And thus, you have proved the left-hand side is a subset of the right-hand side. All right, so any question on this problem? Cool.
Excuse me?
Uh-huh.
Yes, so last question, we just need to prove the left-hand side is a subset of right-hand side. We don't need to prove right-hand side is subset of left-hand side.
Yes. So if we're proving that the left-hand side, sorry, the right-hand side is also a subset of the left-hand side. So we're just trying to prove this way. And if you also want to prove this way, that's the problem. That's where we're actually proving is the equality of this two.
Oh,
We're only
okay.
trying to prove it's a subset, but not equality.
Oh, okay, thank you.
Yeah, for a set equality, you have to prove they're subsets of each other. All right, let's move on to the next one. All right, so I will give you guys about 3 minutes to work on this. All right, so anybody want to start the proof?
Okay. So at first we use distributive. We got the A union, not A, and intersection A union B, and then we use the negation to get the U is union, universal set is union, well, is intersection with A union B.
Sure, the second step would be using negation.
Yeah, negation. And I think then in the commutative to switch the position with universal set and A union B.
Mm-hmm.
Then we use the identity to get the A union B.
Yep, exactly. And I believe this should be the easiest way to do this. All right, anybody has any question on this one? Cool. All right, so the next question is another sub problem. I think it would be easier if you just start by just let a equals to the n squared minus 1. Just like easier to write. And then the question becomes, want to show that A intersects B is a subset of C. All right, I will give you guys some minutes to work on this. All right, so how are we going to start on this one? Like, what would be the first thing you wanted to do?
So by the definition of the intersection, it should be the A set is intersect with B set, so it means n square minus 1 is equal to k. And
Okay, so you're saying that we can start with just that x belongs to the intersection of the set A and the set B. And then we can see that since x belongs to the intersections of A and B, and then x must be belongs to A, which this will give us x equal to n squared minus 1. And then similarly, x would also belongs to B, which would give us x belongs to 2k. Yep.
Yeah, so I don't want to so is the n squared minus 1 should equal 2k because they are intersect.
Mhm.
And so n squared is equal to 2k plus 1.
Yep. You just plus 1 on both sides.
Yes, so n squared is odd, and I'm not sure by what definition, but if n squared is odd, then it's odd, so n is equal to 2 whatever alphabet, 2g plus 1.
Yeah, exactly. So we have this n squared equals to 2k plus 1. And we can tell that 2k plus 1 is actually the definition of odd. So
Yeah.
right here, we can say that by the definition of odd, n squared is an odd number. So I think it's one of the theorem on the textbook that said if n squared is odd number, then n has to be an odd number as well. So we can, and also by the definition of odd, n must be equal to something like 2j, like you said, 2j plus 1, where j is an integer.
Yeah, so just like this back to the n square is equal to g plus 1 square, so it's equal to 4g square plus 4g and plus 1.
Okay, so you're saying that we want to substitute this n equals to 2j plus 1 back to the original equation where we have n squared, where we have the x equal to n squared minus 1. So now we have x equals to n squared minus 1, which is 2j plus 1 squared, and then minus 1.
Yeah, some sort of that and then we got the result is the 4g square plus 4g plus 1 and minus 1 so it's equal to 4g square plus 4g square. Yeah. And by the closure property of integer, we can got the for c, and the c is g squared plus g.
And yep, and just by the closure property. By closure. Oops. So we have proved that it's, or maybe it's better I should use m. And now we have proved that x is also an element in set C. And then you can conclude that the intersection of these two sets is a subset of C.
Yeah, so some sort of like because n squared minus 1 is equal to some sort of 4c, and it's equal to k. So k is also like 2k is equal 2 times 2 whatever alphabet, like 2d or something else. So these two intersect is the subset of 4m.
Mm-hmm. Yep.
Yeah.
All right. Anybody has any question on this one? I think the key part for this question is to recognize that right here we have the n squared minus 1 equals 2k, and we can actually recognize that n squared is an odd number here. And just by the using the theorem, we know that n has to be another odd number. All right. So the next question is to rewrite the following set equalities in Boolean algebra notation. So for the Boolean algebra notation, we should have like the dot and then the plus and then the sign for a complement. I will give you guys about 2 minutes to work on this one. All right, anyone wants to give a shot?
I can do it.
Go ahead.
So first off, we'd start off the left side and we replace it by the complement and negation. So it becomes A and B and B and C, and then that's negated.
And remember, we want to write that as lowercase.
Yeah. And then we'd make all the ands little multiply signs. And then all of a sudden you're in Boolean logic and Boolean algebra. And then basically you just do distributive. You distribute the A and, well, no, you use De Morgan's first. I would use
Okay, so I think for this question, you only want just to translate that. We don't have to prove this.
Oh, wow. I
Yeah.
totally did that too. Yeah, no, that's A times B times B times C.
Yeah, and that's all you need to do for this question.
Awesome. And then the other side is, well, you do the same thing. it's A times B times C naught.
Yep. Yeah, that's correct. And that's all you need to do for this one. You don't have to prove.
I thought that intersect was plus, but it's multiply.
Yeah, it's a dot. The plus is the union. All right, any other questions? Great. So the next one, it actually asks you to prove the equality, where in this time we're giving an assumption that A times B equals to A, and you want to use this assumption to prove that the A complement plus B is the universal set, which is equal to 1. So start from the left-hand side. Think about how you're going to use this assumption to get to 1. And I will give you guys about 3 minutes to work on this. All right, how are we going to start? So we have the A complement plus B, which is like the A complement union B. And then we're given that the intersection of A and B is just A.
So you could substitute AB in for A.
Mm-hmm. And that's just by substitution. And remember, this one is actually A dot B, a complement. And what can we do next if we have something like this?
You can use De Morgan's law to turn it into A naught plus B naught.
Exactly. And we're actually
Oh, plus
using
B.
this one. Yeah, this De Morgan's law. So that becomes A naught plus B naught and plus B. That's De Morgan. All right. And what about the next step?
You could use associative to change it to A naught plus quantity B naught plus B. And then using negation. Wait, negation, right? Yeah, you could turn that B naught plus B into the universal. I guess it's not a set, so it's just one.
Yeah. And it would be better if we can apply the commutative first,
Oh, yeah,
because we want to match as the exact order.
that's right.
And then we can use the negation.
Although it'd be A naught plus one.
Yeah, sorry. So using the Boolean algebra, yeah, the universe is going to be just one. And then what about the next step? And it should be the last step.
Using universal bound, A naught plus one would just become one.
Yep, exactly. So we're going to use this one. All right. Any question on this problem? So, okay, so I guess we can stop here. I will stick around for about 5 minutes. If you have any more questions, you can stay and ask. Otherwise, you're free to leave. Have a nice day.
Yeah, I have a question about the homework. Can I ask about question, let's see, 5 on homework 3?